the exercise of true and false, even homework, and child comes to you and says, what is true, what is false? Delhi is the capital of India. Yes, then that's true. So Delhi is the capital of India. And then the child understands and can fill the table. Now the difficulty is no more about true knowledge. It's a simple matter when it comes to sentences of this kind. This was an eye-opener to the whole philosophical world in 1930. Okay, so another example. Chennai is in Punjab is true if and only if Chennai is in Punjab, and so on. Okay. But then why do you need the notion of truth? It is indeed needed not to say that blah 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 is true, because instead you can simply make that statement, but when you want to generalize. So here's a generalization. For every closed sentence A, the sentence A or not A is true. You couldn't have said this without using this expression true. Or to tell you an old Sanskrit saying, which is Baba Vakyam Pramanam, which means whatever Baba says is true. Suppose you did not have the word true, did not have the word praman. Then what will you say? You'll say, if Baba rises in the sun rises in the east, and if Baba says 2 plus 2 equal to 4, then 2 plus 2 equal to 4, and if Baba says fish fly in the sky, then fish fly in the sky, and this will never end. You won't be able to form a sentence. So you need the notion of true in order to say something like this. Now, there's a kind of truth called logical truth. Let's look at it. Logical truth only depends on the form of the sentence. There are two ways of defining what is logically true. And as I said, my slides are going to be available to you afterwards on the web page of the Pratishthan. And these are somewhat deep matters over which you have to mull and repeatedly read. So you can read it now, but to really understand it, you have to mull over it. It takes some time. So by this definition, a closed sentence in a first order language. Now at this point, I must point out something peculiar. You see, mathematics is the study or the science of all kinds of structures and relationships. And therefore, even though logic is at the foundation of mathematics, logic itself has a lot of structures and relationships, and the study of those structures and relationships therefore becomes subject matter of mathematics. And so in order to study logic to any depth, the main tool is mathematics. So now inevitably a bit of mathematical terminology is going to creep in my explanations of logic. So now when we talk of interpretation of a language, you have to have cells whose members are the possible values of the variable, etc. X. So where are these X, Y, he, she, blah, blah, said, talking? That's your domain of interpretation. Now a function and names are going to be particular individuals in D, okay? Particular elements of the set D are various proper names in L. So D may be the set of citizens of Greece, and then the name Socrates goes and refers to a particular individual. Okay. The chosen function, mother of X, takes you from the set of people to the set of people. And the oldest child of X and Y takes two individuals and takes you, and so on, so on, so on. So your functions become such mathematical maps, and predicates become subsets of D. So you say dot 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 is white, so all the white things form a subset here. Dot 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 is red, that's another subset, and so on. So then the X less than Y defines a subset of N cross N. So all your predicates of one or more variables form subsets there. Now with this, I can define what is true. The equality sign, of course, I need not just these, but the usual standard things in all languages. So there's equality, there is not so and or implies. There are standard interpretations indicated by the mathematical sentence that will arise out of making those replacements is true. And when is an individual mathematical sentence true? That we already explained on the previous page with okay, so this is the notion of logical truth. Now when there are open sentences, an open sentence is true if for every replacement of the variable you get an individual true sentence. Individual true sentence as the truth of the individual sentence 2 plus 2 equal to 4 is true if and only if 2 plus 2 equal to 4. So with this, now I'm going to give you some examples of logical truths. So here's an example. If A implies B and B implies C, then you can conclude that A implies C. This kind of a logical truth is called tautology. Note that it did not involve any variables, quantifiers, etc. So here's something which involves variables and quantifiers. If it's not so that all x satisfy px, then there exists some x which does not satisfy px. This is logical truth. It doesn't depend on what is this predicate p. Now how about this one? If there exists some x which has the property px and there exists an x which satisfies the property qx, then does there exist some x which satisfies both those properties? Clearly not. There may be, there may not be, but you can give one interpretation of x and p, q, etc., where it is satisfied, another where it is not satisfied. And so it's not a logical truth. How about this one? If for all x, px holds, if everybody has blah, blah, blah property, then he also has that property. Yes, because he is one of the everybody. So this is also a logical truth. Okay. Now let us look at the notion of logical consequence. Because arguments, in an argument, the conclusion is a logical consequence of the hypothesis. So let's look at logical consequences. So if I have a sentence in my formal language, I say it's a logical consequence of some sentences B1, B2, etc., which will be called hypothesis. If any interpretation of the language that makes each of these hypotheses true also makes the sentence A true. So logical consequence means it remains true under every interpretation, every possible interpretation that makes the hypothesis true. Now, this seems a very impossible condition. How do I go around checking that every possible interpretation leaves it true, right? It's a very ideal definition, but can it be fulfilled? Now, in particular case of this is when you are not assuming anything at all. So logical truth is just the logical consequence of the empty set of assumptions. Okay, so here are some examples. And here is the standard notation. If I have a set of hypotheses and it has a logical consequence, then there's this symbol. And if on the left-hand side there's nothing, then instead of writing an empty set there, one simply leaves it empty and says this for logical truth. Okay. Now, here's an example of a logical truth. That if I have this, with my hypothesis B1, B2, I could have B1 and B2. I could have kept here the set B1, comma B2. Hello? Yeah. So this is an example of a logical truth. This is an example of logical truth again. Okay. So this is logically true because give any interpretation to B1, give any interpretation to B2, this implication is always there. Give any interpretation to B and then B or negation of B is necessarily true. Here's another. Okay, you read it. This is slightly more complicated for people who are not used to reading such things, but very, very easy. So instead of explaining, I'll pass over it. Either it's very trivial for you or it will take more time. Here's another very, very important kind of logical truth. This is called generalization. If this is true,
then I ask a question. Can you go back to the last slide?
yeah.
Is the first one you are saying is true?
Yes.
B1
No.
or B2?
I'm asking you, is it a logical truth or not? This one is not.
Sorry.
Yeah, it
Yeah.
is false. Yeah.
If there was and here, it would have been a logical truth.
Correct. Yes.
Okay. So you have to pay attention. You were paying attention. Some of these may be, some of them may not be. Okay. Okay. So now at this point, one can ask, let's go back one slide. So here was this logical consequence. And here was a special thing called logical truth. You can ask, if you give me something, then how do I know whether it is a logical truth? Is there some mechanical procedure in which I can put as an input the candidate sentence and output will tell me whether a logical truth or not? It's reasonable to ask this question because as we saw, logical truth just depends on the form, that is the grammatical structure of the sentence, and not on the meanings of its simple constituent predicates, any particular meaning. So it's reasonable. Is there such a way of telling logical truth? If there is such a mechanical way of generating a set of